I'm Barry. I'm co-founder at vquest.io. And what we do at vQuest is carbon analytics for architects and engineers. What we've done is we've built plugins for their software for SketchUp, ArchiCAD, and Revit. And what it does on its most basic level is it analyzes what the architect and engineer has designed and gives them analytical feedback on carbon, cost, and building mass. And what that allows them to do is to select the proper materials or select the best materials in the best place, allowing you to optimize your design as you design. So as you run through your design process, you're effectively specifying materials. From the earliest stages of design, vQuest can actually give you feedback on those materials, even when they're just conceptual, allowing you to run comparative analysis of different materials to see which is the best material use in that type of building or in that methodology that you're designing. It's important that you assess carbon and cost together, because it's pointless that you reduce as much carbon that you have, or it's pointless reducing carbon as to a point where you can no longer afford to actually build the building. So this is why we've integrated cost into that analysis. We've also integrated mass into that analysis, or building weight, because often we find that there's opportunities to reduce carbon and actually increase developers' profits, or even reduce costs of the buildings by reducing the mass as well. So once you have those three analytics together, you start to get good outcomes. What we've also done is we've designed a life cycle analysis tool for carbon. So you've got Brands LCA Quick here in New Zealand that's going to be used as the compliance reporting tool when the new legislation comes out. And what we've done is linked our data to Brands LCA Quick, and we've automated the entire process, making it a streamlined exercise so that you don't have lots of hours involved in just manual input of your findings or of your quantities into this report. We have started working with the Super Homes movement, and the reason we've started working with them is because of their methodology of base, better, best is very, very much aligned with what vQuest does. It allows you to see what you can do for the money that you do have. So again, if you've got access to cost data within the Super Home movement or within the vQuest application, you can decide what fits your budget, and you can decide how far into that sustainability or into that efficiency of design that you want to go. It allows you to get the best possible outcomes for your project whilst not topping it over by making it too expensive. So one of the great things about vQuest is the flexibility of the application. If it can be designed in Revit, SketchUp, or ArchiCAD, it can be analyzed for cost, carbon, and building mass. So that means that there's a level of flexibility there from new build into existing and renovation as well. Again, allowing you to analyze the new parts of the building and compare that potentially even to a new build, so that you can see the comparative analysis between your carbon emissions and your costs for a new build versus a renovation of an existing property. Okay, so vQuest is an application that's going to be used by architects and engineers, and it'll be plugged into their existing design software. However, what vQuest is also doing is collaborating with Super Homes in the development of a phone application or a tablet application that would allow homeowners to get insights into carbon reductions and the efficiency of different systems, as well as the cost of those systems, so that they can actually make good decisions when they're designing their home as well. So carbon lifecycle analysis is quite complicated because it involves a number of different modules. You've got embodied carbon, which is the carbon that's emitted in the construction of the building. But then you've also got operational carbon, so the electrical systems in your building, potentially solar panels, heat pump systems, and the operational cost and the replacement cost or maintenance cost of those systems as well. So it can get quite complex, and there's a number of tools out there that Brands and NBIE are releasing to do that complex analysis. The intention is that vQuest plugs into those tools as well and allows an architect or an engineer to complete those complex analysis really quickly and really efficiently, but it is a complex analysis. vQuest is unique in the way it approaches things. The carbon analysis is unique in the way it approaches that. There's nobody else anywhere in the world that combines the analysis of cost, carbon, and building mass together. And again, as we said earlier on, it's fairly critical that you analyze all three together, because if you don't, you're only getting a blinkered view on the outcomes. You could effectively build too sustainably and not be able to afford to build it. There's nobody else worldwide integrating those metrics. Yeah, MPI. It was we were already fairly involved with tech in the quantity surveying pricing of buildings. So what we were doing is we were already taking architectural models and we were embedding the cost data in their design. so that when you changed a material or changed the shape of something, it would automatically update the quantities and update the materials and update the cost of those materials. And MPI saw that we were working on that, and they basically got us to do a number of their buildings within the mid-rise wood construction program, that program was designed to try and promote the use of sustainable products. And they saw that we could swap materials really, really quickly in the architect's models and update the pricing and do an analysis of comparing one to the other. And they went, "This is fantastic. Can you do it for 25 of our buildings?" And we said, "Yeah, absolutely. We can do it for 25 of your buildings." We started doing it, and they came back to us and said, "Can you do carbon?" And we said, "What's carbon?" And they said, "Here's some documentation you need to start learning about." So we started reading into it. We began to realize that there was legislation coming out worldwide around carbon legislation. And we started embedding that carbon data into our models as well. And we started seeing patterns emerge around cost, carbon, and mass, and how they interacted with each other, and what a good outcome looked like and what a bad outcome looked like. And we realized that there was actually a huge amount of missed opportunity to reduce carbon in construction that has just been missed every single day. So we had software basically that did it in-house, and we decided, you know what, actually we could probably develop something that could be commercialized and used by architects and engineers from the earliest stages of their project.
And carbon emissions seriously?
They're definitely not taken seriously, but a lot of that is down to just a lack of awareness. Like, we're speaking to people every single day that go, "We've never heard of any of this. Why has nobody told us?" Architects, just completely oblivious to the fact that carbon is going to become a major, major issue in the construction industry over the next 5 to 10 years. There's just a complete lack of awareness. But there's some people that know. There's more people that don't. So effectively what's happened is New Zealand has signed up to the Paris Climate Agreement along with 197 other countries and states. And what that means is that we've committed to reducing our carbon emissions across all of our industries by 35% by 2030, and making it net zero, which means we're offsetting as much as we're emitting by 2050. That's called net zero. MBIE are backing that legislation, are backing that commitment up with legislation, just like Australia. France is currently releasing legislation. The UK is releasing legislation. A number of states in the US are currently releasing legislation. And it's happening worldwide across those 198 countries and states. MBIE's legislation, they have a roadmap for delivery, which was the first tranche of that legislation was due in 2024. That has slowed down with the change of government, but we're expecting that because we've signed up to the Paris Climate Agreement, at some point fairly shortly, that legislation will have to become live. That legislation effectively is in 3 tranches. That first tranche of that legislation is mandatory carbon measurement. So when you submit a building consent, with your finished design, you will mandatorily be asked to measure the carbon that's in that building and report it as part of your consenting process. Within 12 months of that, the idea was that there was a second tranche of legislation comes out that set a threshold of carbon that you could have by building type. So for instance, a house would have a certain amount of carbon in it that would be acceptable. If you exceeded that threshold, well, then there was the potential that you either had to redesign or pay for offsetting costs of what you exceeded that threshold by. Followed 12 months after that second tranche of legislation, a third tranche would come, and it would be a reduction of that threshold, making it harder to meet the threshold and forcing you again to reduce the carbon that's in your designs. The idea being is that we meet our 2030 and 2050 targets. So part of the carbon calculation process will be the selection of materials that you're going to use when you're building and comparing them with each other. To date, we've probably had compliance requirements that would make that choice a little bit more difficult. You'd be comparing materials based on performance. Cost was another metric that you might have been analyzing. But going forward into the future, you'll also be analyzing the performance from a carbon perspective or carbon emissions perspective. Some materials emit carbon, some materials actually store carbon. Timber is a great example of a product that stores carbon within it and stores it in your building for the lifetime of that product. Concrete at the moment is a product that emits, and so is steel. So swapping out timber for steel and concrete products would be a good way of reducing carbon in your building. The the way we're going to analyze these buildings or analyze that going forward is that every product that will be used in the construction industry in the future will have to have an environmental product declaration, or what's been abbreviated to EPD. And effectively, it's a specification document that tells you how that material performs from a carbon perspective, from its mining from the ground right through to how you dispose of it, or at end of life, what you do with that product. And the steel and concrete industry are going to see the timber industry as a threat, you know, to their market, because it's going to make massive inroads because of this carbon legislation. But it's also driving innovation, because concrete and steel aren't going to just give up and walk away. We've got some fantastic things like Firth Concrete looking at low potash concrete, which will reduce the carbon that's in their concrete. So already they're starting to innovate and figure out ways that they can reduce their carbon. And then there's a couple of other companies. There's a fantastic one here in Christchurch called Aspiring Materials. They're a group of scientists out of University of Canterbury. And what they've done is come up with a chemical process, and I'm not a scientist, so I'll probably describe this really poorly, but what they've done is come up with a chemical process where they deconstruct aggregate back to its elements, individual elements, and they use another chemical process basically to have it absorb all the carbon in the atmosphere around it, and then put it back together. And then they can just put that in concrete, and then concrete will become a carbon negative product. Or it'll store the concrete for the life of its product, or they'll put it under roads and it'll soak up carbon. You know, so again, they're all game changers for the concrete industry. And the steel industry needs to innovate on how much energy they use to produce steel. If they can do that, well, then they potentially also have a lowered concrete or lowered carbon product. You know? Yeah. And there's places where the timber just doesn't work. You can't use it. You know what I mean? And you run the analysis to see if it'll work, because it's got positives on time and it's got positives in carbon reduction. In some cases, there's a cost premium to it, but then there's places where it just can't perform like steel and concrete, so you can't use it. You know what I mean? So it's about selecting the right material in the right place. It's not about saying it has to be timber all the time or it has to be a sustainable product all the time. It's about using the right product in the right place to get the best outcome. So we've a case study on our project that we worked in recently that proved the point that the carbon reduction opportunities are just missed opportunities, or there's a huge amount of those missed opportunities. We had a developer on the North Island was building apartment blocks. He was building 5 of them. They were 5 stories high, and he'd built them with steel and concrete design. And he had realized that if he wanted to build more of these in the future, that design would probably have to change with this new compliance legislation. So he asked us to run an analysis using VQuest of what that building could look like from a carbon performance perspective if he changed some of the materials over to more to lower carbon products. So we ran an analysis of swapping out the structural steel frame and the concrete floors with LVL and CLT. And we came up with an optimized design. And again, this is about using the right materials in the right place. We felt that the steel actually offered more benefits than the LVL frame in that instance, not from a carbon perspective, but from an efficiency and good outcomes for the project. But the upper concrete floors and the external till panel walls we swapped out for a combination of CLT and lightweight timber frame walls. And the upshot, or the result of that analysis, showed that had he designed the building that way from the very beginning, he would have reduced 3.75 million kg of carbon from his building, or eliminated it, or prevented it from being emitted. And that's the equivalent of driving from Auckland down to Gore 8,000 times. So it's a significant saving, but more importantly, those savings actually cost nothing. So had he designed it like that day one, it would have cost absolutely nothing. And one of the other metrics we do analyze is that building mass. We mentioned that earlier on, and it came into play on this particular project in a big way, because using those lower carbon materials, the likes of the CLT floors instead of concrete floors, reduced the weight of his building by 1 million kg. Now that had a knock-on effect on the foundations that allowed them to eliminate the 16-meter deep piles underneath the building, and it allowed him to go 2 floors higher with the ground capacity. So straight away, that developer decided it doesn't make sense to build them the way they had designed them, even for these first 5. He went back and he redesigned his buildings to be hybrid steel and timber.